Shown opposite is the net for a cone with a base of radius or centimeters. So here is the base of the cone. It's a circle and it has a radius or centimeters. And this is the other section of the cone that folds together to form the actual pointed part of the cone. So we have a radius of the larger sector of a circle to be 10 centimeters and the interior angle to be 6 pi over 5. Part 1, find the value of r. So we want to find the radius. So the arc length of the sector, so this is the sector here, is equal to the circumference of the circular base. So if we were to put these two shapes together and fold them into a cone, this sector, this length of this sector, or length of the circumference of the sector, would line up perfectly with the circumference of this circle. So we need to find what the arc length is of the large sector. So in our formula book we have a formula for arc length, which is L equals r times theta, where r represents the radius, which in this case is 10 centimeters, and theta represents the angle, which is 6 pi over 5. Now theta has to be in radians, so that means it has pi in it. So it's very important that we have our calculator in rad mode. Whereas if the angle had been given in degrees, we could use our other arc length formula. So the length of the arc is going to be the radius times theta. So it's going to be 10 multiplied by 6 pi over 5, and 10 by 6 pi over 5 is going to be 12 pi. And the formula for the circumference of the circle, which we know is equal to the arc length, is going to be 2 pi r. So it's going to be 2 pi r is equal to 12 pi, because that's what we got the arc length to be. And then we just have to solve for r. So we're going to divide both sides by 2 pi, and we're left with 6. So the radius of our circle, which is the base of our shape, is 6 centimeters. So part 2, use the net to find the total surface area of the cone and give your answer correct to 3 decimal places. So the total surface area will be the area of the circle plus the area of the sector. So you find the area of both, add them together. So remember, we now have this radius to be 6. So the area of a circle is pi r squared. So it's going to be pi multiplied by 6 squared plus the area of the sector is going to be A, representing the area, equals a half times r squared times theta. Or we know is 10, and theta we know is 6 pi over 5. So it's a half times 10 squared, so times 6 pi over 5. So pi times 6 squared is 36 pi. A half times 10 squared times 6 pi over 5 is 60 pi. Adding them gives us 96 pi. And pressing SD to get it into a decimal and rounding it to 3 decimal places gives us 301.593 centimeters squared. So it's very important that we used this formula because we were given our angle theta in radians. So we have to use this formula, and our calculator has to be in rad mode. Part 3, calculate the height of the cone. So we're going to let h be the height of the cone, and we're going to draw out a right angle triangle. So we have 10 being the hypotenuse of the right angle triangle. So we got the 10 from the sector of the circle, the radius of the sector of the circle. The radius is 6. We got that from the last part of the question. So now we're trying to figure out what the height is. So we've labelled that as h. So here's our right angle triangle, and we can label it as A, B and C. Because it's a right angle triangle, we're going to use the theorem of Pythagoras to find the unknown side. So Pythagoras' theorem says that c squared is equal to a squared plus b squared. So the c squared is going to be 10 squared, and then we have equal to 6 squared plus h squared. So 6 squared plus h squared is equal to 10 squared. 10 squared is 100, minus the 6 squared, which is 36, leaves us with 64. So if h squared is equal to 64, then h is equal to 8. So this height here is equal to 8 centimetres. So now that we have the height of the cone, we can find the volume. So the formula for the volume of the cone is a third pi r squared h. We know that the radius of the cone is 6 centimetres. We got that from the first part of the question. The height of the cone is 8. We just worked that out. And a third times pi times 6 squared times 8 is 96 pi centimetres cubed. And we want to keep it in terms of pi because that's what it said in part 4 of the question.